Greetings of the day. I'm Ganesh, and this is my official submission to CANIS Data Analysis Hackathon. I believe that data analysis is more about drawing the insight from the data rather than just looking at some scores or the technicalities. So, in this case, I set out to find out what sort of insights or what sort of studies we could perform on this news data set that we could not understand from just a model. So, from this data set, once we start with the visualization of the data frames, we can see that the true news is generally presented in highly positive tones, whereas the false news is generally more negative or varied on the spectrum. And let's just look at a histogram of the sentiment analysis that we did on the news. And you can see for the label true, which is the collection of all the true news, it is generally on the spectrum's right side end, which is towards 1. And this sentiment analysis score basically tells us how positive the sentiment is in a news article or in a string data, right? So you can see that generally the true news tends to be more positive, whereas the false news is more varied across the spectrum. And once you get to the most negative side of things, it's generally the false news. The next thing that we observed was the stop words of vulgarity is more common in false news compared to true news. So yeah, stop words or vulgarity is one thing, but we also took into account the number of words, the punctuation marks present, and the word count generally in the news content, right? So if you just look at a box plot of the same, you can see that for normalized word count, where the word count is same across the false and true news, you can see the false news has a more tendency of having more stop words per word count compared to the true news. But even then, I would say that this chart tells us more similarities than differences because you can see that there's not a very distinct difference between the false and true news side. So we can't really say that, yeah, false news will always have more stop words, right? Moving on, capital letters are thrown more around in false news compared to the true news. Yeah. So if you look at a capital count basically of the normalized word count, you can see that the false news has more capital letters or human annotations compared to true news. The top features which are present in both true news and false news, according to this dataset, mostly deals with politics. So we did a basic topic modeling model on top of this to understand what sort of topics are being thrown around in the news articles. And we see the key highlights were Trump, Hillary, and Clinton. So I would say that maybe the coming up election is something that has influenced the dataset. But nevertheless, it is very interesting to see that most of the news that deals with politics is what is present in the true and false part as well. So, if we study the true top features which were distinguishing the true and false news, it was actually some factual entity. So let's say it was something like a quotation of a statement or days of the week or something on Twitter that really separates the true and false news, which is very visible from this chart. You can see that the top 10 indicative features of true or false news were generally the days of the week, something like said or follow, which is a quotation of someone, or Twitter. So I would say that most of the true news comes down to the facts. So a news something that was said something in the sense of Donald J. Trump quoted or said so and so on Monday, but while it was said actually on Tuesday or Wednesday. So I would say that the Tuesday or Wednesday thing is actually labeled as true news, whereas the Monday thing might be labeled as a false news. That is why we have this feature. But moving on, then we have a simple logistic regression model which has accuracy of 93.6% in detecting true and false news. This was just done on a simple ML model where we basically just divide the data set into a train set and a split test set and just go ahead with it. But what I think is most interesting is I believe this data set has given us an understanding that true news and false news have become increasingly more similar rather than apart. In the previous parts, we could just look at the source or we could just look at the headline of a news and make out that, yeah, this is probably fake. But right now, this data set basically shows us that most of them are really similar. Apart from two or three things such as my sentiment analysis model, the stop words count, I think all the other features such as let's say word count, punctuation use, they were all very similar. And some of the technicalities such as let's say if we look at, I'll just show you over here, let's say the n-grams, or when we look at the average gunning fork index, we see that the false and true news are actually very close. So this is not something that a human or a normie like us would probably be able to make out, right? So what should we do? I think the necessity of the hour is to have a deep understanding of what might distinguish these two pieces of news, which are very similar to each other, but only one is among the true, right? So this reminds me of a game which was called One Truth and Two Lies. So there will be three statements, two of them lies and one truth, and we have to figure out how we can do that. But this is easier said than done. If we could identify key features which distinguish the lie and the truth in our daily lives, I believe it would be better for us all of us regular people to understand the information better and discard information better, which I think is really important at this point. Sadly, this was not a simple model to make, but we'll just go ahead with what we have here. So, to do this, what we did is here we'll talk a little bit about the technicalities, where we look at the similarity scores between the news content that we have. So, what is a similarity score? A cosine similarity score, in this case at least, refers to the score which is assigned to the strings which are very similar to each other. For let's say two news articles which have a score of let's say 0.8 or 1, the more they lean towards 1, the more similar they are. The more they lean towards 0, the more dissimilar they are. So in this case, what I aim to do was to look at the dataset to find the groups of news content that was really similar to each other. But sadly, as I do not have any GPU, this was taking a lot of time. It ran for 670 minutes, still no results. So, given the time restrictions of the hackathon, I had to scrape this. But I really want to walk this through because I have really thought this through as well. So once we have the cosine similarities, what we can do is we can define a threshold. So this threshold would segregate the news articles which are really similar to us and then give us an insight as to, yeah, if one of them is false, because we're grouping them by the labels, right? So if one of them is false and one of them is true, what are the features that distinguish this two similar news articles, of which they have been categorized as false and true? So once we have the similar pairs of news here, then what we can do is we can look into a count vectorizer model or a logistic regression model or whatever to understand what sort of features are distinguishing the true and false news at this point, right? So this is something that basically looks at the similar pairs only from the data frame and then categorizes those as true or false and trains the model on top of that. I believe the more similar data we have and training a model to learn about differences among a very similar set of things is what makes a good ML model rather than just training it on the vast, different, I would say varied user content, right? So once we have that, what we have is here there's another model that I tried to implement. There's some binary classification as well. But sadly, due to the time limitations, I could not finish it off. But I'm going to take this up as a personal project to finish this off in due time. So yeah, I did a binary classification and a decision tree to compare how this thing would play out in different scenarios, right? And the last thing that we can do is we can plot the similar features by feature importances, as I call it, so that we can understand which important features basically distinguish a true news from a fake news. Yeah, that has been my journey through this hackathon. I believe that I was not able to complete this part of the thing, which is I think a real necessity of this hour and would give us real insights. But yeah, nevertheless, it has been a great time with you all, and thank you for this opportunity.